Alright, so yesterday we looked at limits from graphs and tables. Today we're going to look at limits algebraically. So remember that we use graphs and tables some of the time, most of they give us, but most of the time, like 75% of the time, we're going to be doing some algebraic. So remember that we have some different methods. So remember, we always want to try direct substitution first. There you go. These are like a whole lot easier. Then remember, we have some basic limit theories. Okay. So our like sine and cosine limit. Some of those. Remember that we can also factor out and then reduce common factors. We can multiply by the conjugate when we have a when we have an irrational. We have special trig limits, and we have L'Hopital's rule. We're not there yet. First up, what do we want to try first? Plugging it in, which is also called direct substitution. So like on this first one, what would we do? Plug into. Yep, and so we get 3 times 4, which gives us 12 minus 10 plus 4. So we get 6. Alright, on our next one, we have a rational. Can I still plug in if I have a rational? Yes, but something we have to double check for. If the denominator is 0. If our denominator ends up being 0, then we gotta do something else. However, in this case, what do we get? 9 over 3, which is also 3. Now, can I plug in irrational numbers like e and pi?
Yes.
Yep. As long as it doesn't make my denominator 0. So, what is the natural log of e?
1.
So, what do we end up with?
3.
3. Alright, and then lastly, again, we have a radical this time, but just because we have a radical does not necessarily mean we need to multiply by the conjugate. If we can plug in, then that's what we want to do first. So we get the cubed root of 8, which is also 2. 2, there we go. Yes? No? Okay.
Yes.
Alright, what about this next one? What do we want to try first? Plug in chart, direct substitution. So we would get 4 minus 12, which gives us negative 8 plus 8, which is 0.
And the top is 0.
Yeah, so we get 0 over 0, which is an indeterminate form. So we have to reduce if possible.
Yes. No, not yet.
Reduce. You want to reduce first. If you can't reduce, then we can use L'Hopital's. So here we can factor this. What is that going to factor to? X plus 3 times x minus 2. And on the bottom?
X minus 2.
Sure.
Okay, so what reduces?
The x minus 2's go away.
Which is nice. Because now I have x plus 3 divided by x minus 4. So now when I plug 2 in, what do we get?
5.
So negative 5 halves. Or negative 2.5, whichever. Alright, what about the next one? What do we want to try first? Plug it in. So we get 9 plus 3 is 12 minus 12 is also 0. You also get 0 on the top. We're going to have to remind ourselves of something important there on the top.
The difference of cubes.
Difference of cubes formula.
That one.
Soap.
Yep, our soap. So remember that it's a squared, b squared, okay? And it's going to be same, opposite, always positive.
Yeah.
So then what is our denominator factor to? So what reduces?
Yes.
Which is nice. That was our issue. So what do we get when we plug in on top of it? So you get 9 plus 9 plus 9.
It was 27.
Which is nice.
Over 7.
Does that reduce?
No,
No.
not in the mixed.
No. Yeah. You read a decimal. Questions on that? So far, so good? Alright. Well, since the graph is shown, we don't need the graph. We're going to do it algebraically. So, what do we want to try first? Plug it in. If we plug it in, what happens?
Bad.
Bad. Okay. So, what do we need to do? This time, we have a rational, we have a radical, so what are we going to multiply by?
Multiply with the conjugate.
Okay, what is our conjugate here?
It's
The second one's
Plus 1. Yep. So remember that we just switched that second sign. What do I need to be careful about when I write my next line? What can I not drop? The limit. So remember that I have not evaluated my limit yet, so I cannot drop my.
what happened?
There were just like 5 students running, like sprinting out of the.
Michael, why'd you pipe up someone's car?
Lovely that that's on our recording now.
Out of this.
Oh my god.
Oh man, we gotta start over. Thanks,
Oh.
Ethan.
No, I can't edit it.
Yeah,
they just out of hours. I mean, they were just busting their butts.
Trying to get to the event center and they're late.
So
I think the opposite.
I think they got in trouble during lunch and we're like hauling butt to get out of it. Back to limits.
Yeah.
Alright, so we don't want to forget our limit symbol because right now we're just doing some algebraic manipulation. We haven't actually done the limit yet, so we gotta leave that limit symbol there. When I multiply this out, my square roots will reduce, so I get x plus 2. Also notice that we'll get a positive square root of x plus 2 and a negative square root of x plus 2, so those will reduce, and then we just have minus 1. Remember on bottom, we just want to leave it in factored form. Because, notice, what do we get on top? X plus 1, which is handy, because we also have an x plus 1 on bottom. And they reduce, so we have the limit as x goes to -1 of 1 divided by the square root of x plus 2 plus 1. So if we plug that in, we get 1. Alright, what about our next one? What do we want to try first?
Plug it in.
Plug it in. We get 5 minus 5, which is 0 on top. We get square root of 9, which is 3. 3 minus 3 is also 0 on the bottom. What do we need to multiply by this time? So we have 3 plus the square root of x plus 4. Again, I have not taken my limit, so we are going to leave that there. We end up with x minus 5 times 3 plus the square root of x plus 4. And on the bottom, I get a 9 minus x plus 4.
Sure.
Yeah.
Yes.
So what is our denominator reduced to?
X minus
Sure.
negative 5
X
plus
plus-
x. Let's flip that around.
Negative x plus 5, right? So what are we going to want to do with that?
Flip flop.
What do we mean by that?
The associative identity.
Nope.
The commutative identity.
Well, I don't just. We have a greater problem than just that they're in the wrong order.
There's negatives.
Yeah. So I have a negative x and a positive 5. Yeah? Which does not match the top. What do we need to do? Factor out a negative.
Oh, wait, I can read.
So when I do that, now what happens? Now it reduces. So you just have the limit as x goes to 5 of negative 3 plus the square root of x plus 4. Now can we plug in? Yep, we get square root of 9, which is 3. 3 plus 3 gives us 6, and then we gotta throw that negative in the front.
Okay.
Yep. 2 down, right? Or I guess technically 3. Direct substitution, factoring, and rational.
Oh, no.
Yay, fractions!
Oh, love those.
Ew.
That's so dumb.
No.
So, again, even if we have complex fractions, which is what these are, I can still just plug in if we can. Notice that if I plug in on the first one, we get a 0 divided by 1/4 plus negative 1/4. So we get 0 over 0. So we do have to do something. Okay? We have 2 different options. One, we can find a common denominator on my bottom and like combine those to one fraction and then multiply by the reciprocal and do all that stuff. Or we can find the least common multiple of any of the fractions and we multiply the top and the bottom by that. So we're gonna do way 2 because it's short. So what is our least common multiple here of our denominator?
It's exponents. Let's just type
So not the greatest common factor. So not what goes into them, but what they both go into. Yes. So like I would have to have a 4 and an x minus 4. So it's my least common multiple of 4 and x minus 4.
Sure.
You can multiply that, but we don't need to. So we're gonna multiply this to the top and the bottom. And the reason for that is I get x times 4 times x minus 4, right? And then notice what's going to happen when I multiply it. So I'm going to have to distribute it to the bottom. So what happens to my 4s? They reduce, so I'm just left with x minus 4. Okay? And then what happens to my x minus 4 is on my second one? They go away, they reduce, so I'm just left with a 4. Well, then what happens?
The bottom is.
Yep, so we have 4x times x minus 4 on top, and then x on bottom. So what happens to our x's? They reduce, and we're just left with 4 times x minus 4, which overall gives us a negative 16. Alright, I want you to try the second one. So our least common multiple this time is 2 times 2 plus x. Just notice, if we plug in 0, we get an indeterminate form. So on top, my 2 times 2 plus x's are going to reduce. So I have a 2. On the second one, I have a 2 plus x. And then on the bottom, we have 2x times 2 plus x. So on top, I get a negative x. So my x's do reduce. So we end up with a negative 1, 4. Be careful about distributing that negative on top.
Yes.
We do have to do that.
Just don't forget that.
I was actually thinking about that.
Yeah, definitely didn't add it just now.
That's alright. Let me still just get back in this way. Now we got some fun ones. That's so fun.
Fair.
And they make our brains bigger.
My brain is too big. It hurts my head, okay?
So I gotta go through the
I've
ones
got
that
too
are.
much.
Alright, so first off, what do we want to try? Substitution, but what happens?
Don't worry.
It doesn't work. We get now. Remember, even from the left or from the right, I can still do direct substitution because if I get an answer, right, then that means that the left and the right are the same thing. So it doesn't matter that it's from the left. However, since we can't, okay, we do have to think about what we have to do here. So what do we have to do?
Let's go a little bit off.
No, we don't want to estimate. what can we might eventually, but what do we want to do first? We might eventually, but what do we want to do first? Yeah, let's factor that. Can I pull anything out? On the bottom, yeah. Can I pull anything out of the top? 2, right? Because the absolute value of 2 would still be 2, so I can factor a 2 out of my absolute value. So I get 2x squared times the absolute value of x plus 6. Now, we said we can factor out of 4, sorry, 3. We can factor out of 4 from the bottom.
Okay, let's go to negative 6.
Make it much harder. Okay, so then now, yes, we have absolute values, which means that we have to look at both cases, yes, a positive case and a negative case. However, which case do we actually really only care about? The negative case, because we are approaching negative 3 from the left, and negative 3 is what makes that absolute value 0, yes? So anything that we plug in that's to the left of negative 3 is going to make that inside part negative. Okay, so we have the limit as x approaches negative 3 from the left of 2x squared times a negative x plus 3. Now, what happens?
We're gonna go bye-bye.
My x plus 3's reduce, so we're left with the limit as x goes to negative 3 from the left of negative 2x squared divided by 4. So when we plug in negative 3, we get negative 3 squared is 9 times the negative 2 is 18 over 4. Negative 9 halves. Negative? That's right. So these are kind of just like some of our special cases, right? Okay, well, technically we factored, but we also had to use our critical thinking skills to think about what does it mean to have an absolute value. Alright, what about the next one? Can we plug in? No, we can't. Can I rationalize? So remember that if I don't have an addition or subtraction, what you would do to rationalize is just multiply the top and the bottom by that radical. So technically we can, except there's a lot going on inside that radical. So what might it be helpful to do first? So factor my numerator and my denominator. So I have the limit as x approaches 3 from the right. What can I factor out of the top?
3 or 4, yeah.
There we go. And then I'm left with x minus 3. Now, what does that inside of the radical factor to? X minus 3 squared. Yes? It does. We have to be a little bit careful though.
Plus or minus.
Because it's technically plus or minus, or we could also think about it as when I reduce these, it technically becomes just the absolute value of that bottom, right? Because since I have a square root, whatever I get as my answer has to be positive, yes? So then basically I'm back to what I had over there. The only difference is this time we are approaching from the right side. So when I drop my absolute values, or if I had put a plus or minus, I know that we only care about the positive because we're approaching from the right-hand side. So I end up with the limit as x approaches 3 from the right of 4 times x minus 3 divided by a positive x minus 3. So I just end up with the limit as x approaches 4 from the right, from 3 from the right of 4, which is just 4. Just a constant. So that's nice. Questions on that? So again, just using some of those algebra skills that maybe we've forgotten radicals and absolute values. Yes? No? Questions on that?